Hello students! The goal of this video very broadly is to analyze graphs of functions. To get a little bit more specific, by the end of this video you should be able to list the relative maximum and minimum values of a function, and you should also be able to write intervals where a function is increasing, decreasing, and constant. In order to dig deep into the meaning of these objectives, I want to take a look at this graph that we should all be maybe too familiar with, and that's the graph of knowledge versus time. So on one axis, or the x-axis, you have time. So time could be the first time you are introduced to material in a lecture, or 2 weeks before an exam, or the day after an exam. On what we used to know as the y-axis, you have knowledge. So do you know the material, and every moment you're awake is devoted to learning it? Or do you not know very much, and, a monkey with a typewriter would do better? Which, of course, this is meant to be in good humor here. But we are familiar at some point in our lives with this graph, so this makes a good way to introduce what the new concepts are. Now, the first thing I want to talk about is how you can figure out where a graph is increasing, decreasing, or constant. What I generally tell students is that you read these graphs like you read a book. So just trace your pencil from left to right and decide if your piece is going up or if it's going down. So if I read this from left to right, I start by going up here, then I go down, then I go up again, then I continue to go up, then I have a downward fall, and then I just kind of flatline. So anywhere I said you go up is where the function is increasing. So for example, from the first lecture to the last lecture, your knowledge is increasing because you are learning more and more. Or from the end of term to the exam, you're going to learn more and more and more because you're going to be studying for that exam. Wherever the function is decreasing is where you are going from learning a lot to knowing less. So that might be from the last lecture to the end of term. Or it can be from the exam until the day after the exam for the rest of life. Because after the exam, traditionally we forget everything. Of course, that happens to none of you, but traditionally speaking, that often happens to students. In terms of constant means that you're neither increasing or decreasing, but you're just staying at the same rate of knowledge. So that may be after the exam, you aren't studying the content anymore, so your knowledge isn't going up or going down, it's just remaining the same. You're flatlining. You're not learning anything, but you're not necessarily forgetting anything either. So in terms of how I'd write this, we'll talk about that in the next example, but this is just an introduction to what increasing, decreasing, constant means. The next thing I want to talk about briefly, before we move on to our next example, is what is a relative maximum and minimum value. For our purposes, we talk about relative maximum and minimum because a lot of the functions we look at have something like this at the end of them, or something like this, where that means they go on forever and ever and ever. So technically, the maximum and minimum values could be negative infinity to positive infinity. But these aren't really values or concrete values. So we like to talk about what the relative maximum or relative minimum means. And all that's saying is, yes, the maximum value may be infinity, but relatively to the graph you are seeing, or to the window you are looking in, what is the maximum or minimum point on that graph? So the rest of our lives may go on forever, but the relative maximum, for example, would be, where is the point that you know the most? So the point I know the most is the day of the exam, or the day just before the exam. And that's because I know every moment I'm awake is devoted to learning that material. This would be an example of a relative maximum. I like to use this example to just kind of introduce the topics, but we are going to look at a traditional example to reinforce the proper notation ideas. I know, not quite as fun, but very useful to your learning. So the function we are going to look at for the purposes of this discussion is the function named Miss Mancini, where our input is x. Remember, the name of your function can be anything. I like to stray away from our traditional f of x, but if you prefer, you can use that as well. I just say boo. Okay, so let's look at this function. I have it plugged into my graphing calculator. You can take a look at mine, or you can plug it in on your own as well to follow along. So this is what that function looks like. I have 1/4 x to the 4th minus 2x squared plus 1. I don't expect you to graph those on your own quite yet, but we will eventually. The first question I want to answer is, where is the function increasing, decreasing, or constant? So again, you want to read this like a book going from left to right. Keeping in mind the left technically goes on forever and ever and ever. but we'll just look at the window where we can see most of the function. So once I start from the left, my values are going lower and lower or lower, or I'm going down on the graph. Then I'm going up, then I'm going down, then I'm going up again. So one example of where you are decreasing is from here to this point, -2, -3. Now the question is, how do I write this as an interval? So I guess one thing you should write on your note sheets is that I always write these in interval notation. Yet another reason we practice this a lot at the beginning of the year. The key word is that it's asking where is the function increasing or decreasing or constant. So what is actually decreasing as you go from up here to down here? The answer is your y value is getting less and less and less. So you start a y value up here is like 15, and then you're coming all the way down to this y value of -3. So in terms of just coordinates and what you're looking at, your y tells you the values at where something is happening, which means your x tells you the location of where those values are increasing, decreasing, or whatever it is you're looking at. Okay, so even though my y values are going down here, the interval I want to write is where is that happening. So the y values are going down from where your x is. Well, since this goes on forever and ever and ever in an upward trend, and it's going slightly to the left, that means our lowest x value where this is happening is at -infinity. And then it stops decreasing at -2. So in terms of my decreasing function, an example would be I'm decreasing from -infinity to -2. If I asked you what values is it decreasing at, you might say something like positive infinity to -2. But I want to know where that's happening. So it's kind of like your domain tells you the location you're looking at on the graph. For domain, you use x, and for these intervals, you use x as well. And an example of where it's increasing, there's a couple. You could use this interval here, or you can go from here to infinity. Since I already did an infinite one, let's use an interval over here. So as I go from -3, I'm going up and up and up and up, and I'm going to 1. That's the value of increasing. Where it's increasing is from -2 to 0. And so my interval would be -2 to 0. Again, the tricky thing is, technically, when I'm looking at the decreasing function, my x values are going up. -infinity is less than -2, so these are going up. The reason it's decreasing, though, is because we're looking at the y being decreasing. The x's, again, just tell me where this is happening. So I'm writing x's all over this. So you remember that we write the interval with our x values. So from -2 to 0, my function is going to go up. Now notice I use parentheses on all of these. That's because at the value of, say, 2, this value here, you're not actually increasing or decreasing at this point because technically you're increasing and decreasing. I mean, you're going down here, so it's included in that interval, but it's also included in the interval going up. So we always use parentheses when we write these intervals because at the value of -2 or at 0, you are not increasing or decreasing. It's changing which direction it's going. So I just say always use parentheses. Now, there are a couple more intervals we can write. I'm just going to do an example of each. You can write the others on your own. There is no example of a constant on this particular function because a constant would mean that you're not increasing or decreasing. You're just kind of staying the same. So that would mean your y value is not changing, which would mean you have a horizontal line, which we do not have on this function. So in this case, we don't have an example, but we can look at some more in class. So constant, think of a horizontal line. So your y values are going up here, your y values are going down here, your y values would be staying the same in our third example. In terms of the relative maximum and minimum, if you thought about this graph, you might say like, hey, this graph is going on forever to infinity, so isn't the maximum infinity and the minimum -infinity maybe? I don't know, maybe not this graph. Okay, relative maximum means what is a maximum value you can see on this function? So this question asks where is the function's maximum and minimum? So the maximum that we can see would actually be this point here at 0, 1. Again, some students might say, like, why didn't you pick this value up here? But technically, that's going on forever and ever. So how would I decide? Like, am I going to pick here? Am I going to pick here? Am I going to pick here? So on and so forth. And that's why we focus on the relative maximum relative to, what we can get a concrete value for. So the first thing I always say is, okay, the point is actually 0, 1. But the question asks me, where is the function's maximum value? So again, x deals with the where, or the location, and y deals with the value. So if I'm asking where is the function's relative maximum, you would say it happens at x equals 0. If I asked what is the value, you would say at y equals 1. That's the highest y value we can see as a relative maximum. A relative minimum actually happens in 2 places in this particular function because they have the same lowest y value, which is -3. So for the relative minimum, if I ask you where, I would say it happens at x equals -2 and +2. So I'll just write this plus or minus 2. And if I ask what value, I would say that minimum value is -3, which the minimum value is actually the absolute minimum in this graph as well, because this graph will never go below -3. So that's a little bit about how you write increasing, decreasing, constant, and relative and maximum values or intervals. One of the most important parts of this video is that your y tells you value, whereas x tells you location. So I hope you learned a lot. I hope you have a kind of interesting graph to look back at if you forget the concepts. And please come to class with questions. Have a good night.